With great data comes even greater access latency. Welcome to the Presto Community Broadcast, where we transform your latency woes into fast insights. I am your co-host, Brian Olson.
And I'm again Manfred Moser.
Presto Community Broadcast is a show where we cover events and happenings within the open source Presto community and show off a little bit of cool stuff about Presto. How's it going, man?
Busy as always, but having a good time.
Yeah.
So good.
Yeah, same here. Definitely a couple things cropping up in the EMEA community, and so we'll be covering that a little bit, and a couple pieces that we're interested in getting ourselves introduced, like concepts that we're interested in getting introduced here, and moving towards a topic we actually discussed on the 0th. I'm going to call it the 0th episode of Presto Community Broadcast. That was the dynamic filtering. So we actually...
That was like the -1 episode.
Yeah, there we go, -1. Yeah, because I mean, depending on how you're looking at it, 0 is very legitimate. Yeah, so the null episode that happened was basically we sat down with Carol Sobek and Ranak and Maralka, and we talked to them about dynamic filtering. And so I think... going in, this was the very first episode, and we weren't really having too much of a plan. We were just going to start talking about cool stuff with Presto. And going in hindsight, I'm kind of glad we kind of failed to record that episode because it's not like it wasn't a good. I mean, it was a very successful, very cool episode, but I think we were jumping in too fast
in the deep end.
Yeah, I mean, we immediately ran into one of the more advanced concepts of Presto without even giving anybody any time to like understand even the basics. And a lot of our community, as much as we tend not to think about it as much, every community, the majority are beginners, and so. Yeah. So we're trying to be very thoughtful of that, mindful of that, to all of our beginning Presto, or we're trying to think of what we call our members of Presto community, Prestons.
The Presto Prestons.
Yeah,
Prestons?
Yeah, call them the Prestons or something like that. So we basically just want to be mindful that, we need to gradually build ourselves up to something like dynamic filtering. And so today we're going to be covering Hive Partitions. And so you may think, why Hive Partitions? And that's because Hive is kind of the original model that a lot of things in Presto was built on. And so in particular, when you're using the Hive connector,
it's still a massive use case, right? Like, even though it's called Hive, it's all the cloud storage and all the data lake, all that kind of buzz around all that. It's all Hive, basically.
Yep.
Right?
And it's so that the kind of idea here is like, we call it Hive partitioning, but it's not like we're talking about the system or runtime Hive partitioning. It's just the kind of way that you've structured your data, the way that you understand all the data that's sitting in the cloud, that's all stored in the Hive Metastore. And so we're going to be jumping into that a little bit today with the demo, as well as you're going to be covering it in the concepts today. So it's going to be a really super cool episode. We also have a pretty interesting question that kind of gets us into some of the JVM pieces of like the dynamic code rewriting stuff. So really excited about this episode. And so before we hop into that, let's go to a quick announcement from our advertiser, or our sponsors. I'd like to take a moment to thank our sponsors, Starburst, for hosting this show. Starburst is an enterprise offering that builds upon open source Presto distribution. The main vectors you improve upon when moving to Starburst are performance, support, and simplicity to deploy. The performance gains come from an enterprise suite of Presto connectors that improve upon the open source connectors by offering parallel implementations and improved statistics exposed to the cost-based optimizer. There are also connectors that don't exist in the open source projects, such as the Snowflake connector and Delta Lake connector, and many other that prove useful in many enterprise applications. My favorite thing that Starburst offers is how they take away the pain of deployment, security, and scaling your Presto cluster up by offering Kubernetes deployments on multiple cloud platforms. This relieves a lot of pressure from your ops team and offers them a slick user interface called Mission Control that makes the management of your cross-platform clusters easy. Finally, they have a team of experts that are available to address any issues you experience. This team includes the original founders of Presto, a dedicated customer success team, and even Manfred and myself. We clearly think the product is great, but don't take our word for it. Try Presto for free. Head on over to starburstdata.com to learn more. And now back to the show. All right. So, Manfred, release 346. What's been going on the last couple weeks?
It's going fast. Like, it's crazy what's going on. But again, we continued the trend of adding more stuff. One of the one of the amazing things was we included some functions for expanding our SQL support. So it now supports range and groups in window frames, and you can do alter table so and so set authorization statements, which is really useful for a lot of things. On the Iceberg connector, for example, we added the materialized views, and then a lot of things went into the Hive connector, where we did include improvements around the native Hive views support. That came in last time with that library from LinkedIn called Coral. There were improvements there. That was brand new with the 345 release. In 346, we literally found a few little things that got improved. There's some improvements around the Metastore, the Glue Metastore usage. And all the other connectors also had a whole bunch of performance improvements, littler ones here and there. If you look at a general improvements as well, there is a couple of performance improvements for like inequality conditions and other smaller statements, but it's that it always adds up, right? Like you have all these little improvements for various correctness and improvement things. A bunch of those continue our trend that we really had for the last, I don't know how many releases now, where the timestamp and time kind of related higher precision work all the way down to nanoseconds and stuff is more and more improved in the code base in terms of the general functionality of Presto, but now it's starting to really flow out into the connector. So I think the Hive connector now has pretty full support for all the way down to nanoseconds and so on, and all that kind of stuff is very important to go if you go to like financial and like where really like where the time matters for real.
Yeah, exactly. Yeah, down to the nanosecond of who gets the trade, and especially when it comes into anything like transactional, because as we've seen like a lot more things from last episode, we were talking a lot more hype around the transactional nature of stuff that features that Hive offer, and so Presto is now able to expose a lot of those things that initially started in Hive 8, like the Hive 3.0 type stuff. We're starting to port a lot of that over into Presto as well now. So
also a whole bunch of those like correctness of a lot of functions. Like Presto, as you know, has lots and lots of different functions. Yes. A lot of them had correctness fixes, and I think there's also a few more new ones, actually, like one or two. I remember seeing a pull request or two.
Yeah, there's a couple. There's least and like null handlings for least and greatest. Null's always a big bear in these things. And then same thing with not a number. Man, not a number's bitten me plenty of times.
Yeah, so it goes deep.
Cool. Well, looks like we had a lot of cool stuff. I mean, it seemed like this one, there was no like, oh my God, crazy PR, but it was like a lot of like incremental, little things that built up to just making Presto way better.
It was a bit of a follow-up release. I think 345 was our LTS released on the Starburst side, and we really like solidified that a lot. And then a lot of things that like was sort of like miscellaneous things like that didn't just make it for 345 flowed over into the open source 346. We actually had a few critical things that we backported as well. So it's definitely a great connection again, great release again.
Trying to see what happened in the SPI. Always intrigued whenever SPI things come around, because that means a lot of people have to update things on the on the connectors.
Yeah, only if you do your own implementation of other connectors and stuff, and you're touching those aspects.
Yeah. So, but and there's usually not too much, like very, very careful changes I always see made to the SPI, but this one's like propagation of connector session properties, probably a lot of internal stuff more than anything
internal
exposed.
And correctness things. And if there is changes on the SPI, often what it is, it's expansions for further callbacks or functionality, say like an addition to, like, I think the dynamic filtering was one of those things. The SPI needed to have these endpoints so that connectors can implement dynamic filtering, right? So it's just expanding. A connector that doesn't have dynamic filtering, well, too bad, so sad, right? Doesn't matter.
Yeah, exactly.
So it's good.
Cool. All right. So anything else you need to cover with the release, or shall I move on to the news?
Yeah, no, jump right in.
All right. So, just a couple things. Mainly going to be talking about some events that are coming up. So, today, and this is all in Japanese, but for those that are watching on the stream, but very much keen to how the event is going to be run. We have the Presto conference in Tokyo happening. So, it will be tomorrow in Japan, but it will be tonight. And so, myself and Martine will be speaking at this our tonight for us on Thursday, and then tomorrow in the afternoon for Japan. And so basically, just I'm going to be kind of promoting the community as well as this Presto community broadcast. And so hello to everybody from Japan who's watching this in hindsight. So we will be talking there tonight, and the majority of the talks are going to be in Japanese, and it's going to be folks that are going to be just presenting on how they've used Presto and their particular work. We have Arm Treasure Data, Line, and a couple other companies that are very huge Presto supporters, including like a lot of people that work for these companies are actually in our ranks and contributors to the open source Presto community project. So huge thanks to all of them that put this stuff together, and Toru who put this event together. So really looking forward to being a part of that. And then so that is tonight for any of you who are in the APJ or specifically in Japan area.
Looks like you have a long day planned, Brian.
Yeah, it's going to be a long day for me, but always worth it. Really excited to actually get
Totally.
some one-on-one time with those in Asia Pacific. I feel like majority of the beginning, my beginnings here was in meetups in the U.S., and so really just happy to be a part of like any part in the APJ. So talking about other time zones and regions, we also have a couple meetups that have been surfacing lately in Poland. This is Jacek Lakowski, and hopefully I didn't butcher his name, but Jacek has been slowly getting kind of comes from the Spark community, and he does a lot of talks on Spark, but has recently shown some interest in Presto, and so as kind of one of his things, he's been kind of like learning about Presto and kind of sharing that with the community over there in Poland. So next week he's been doing one about every week now. Next week he's going to be covering some Docker and Kubernetes stuff. I only know this because I read the description on LinkedIn in English. This is all in Polish, so so I wouldn't be able to tell you had I not read that before. So this is going to be Tuesday, November 24th, and will be, I think, sometime. Let me see, what is it? Greenwich Mountain Time. Is that Mountain Time? I can't remember.
GMT.
GMT, anyways.
Greenwich Mean Time, yeah.
I know, +1, so I'm guessing that's basically Polish time. So
Yeah.
it's going to be 6 p.m. and I'm not going to do the math, but it's either that's probably 5 p.m. 5 p.m. in Poland. So definitely check that out. It's going to be in Polish as well, but really excited to see that the community there is blowing up. As well, one last thing, and so I'm not actually talking about any single events that are going to be in the U.S. Or any of the Americas this time. So I've talked about a lot of events before that were always all in the U.S., but all of these are going to be EMEA and APJ for today. So this one is going to be in English though. So feel free to join. Everything's virtual nowadays, but this is mainly going to be focused on the our growing EMEA community and trying to bring this to a larger audience from anybody from Poland to Germany to the UK, and so this is basically one that's hosted by Starburst. Now, it's not going to be talking about the enterprise version yet, where this is actually going to be talking about basically how to set up a simple Presto local Presto setup. It's going to be an interactive session too, so we'll actually be sending out when you register here, you'll register with your email, and then we'll actually be able to have you do an interactive training with us. So you'll be running setting up Presto. Actually, Presto is going to get set up for you, and the main thing you're going to be doing is kind of learning how to interact with Presto at a very basic level. Then we're going to show you how to do federated searches, and then we're eventually going to show you how to basically run queries over data data lakes with multiple different formats from, orc in your format to like JSON, and then performing joins between those data types. So that's going to be December 3rd, 1 p.m. GMT, 2 p.m. in CET, which is, I think that's the actual time zone that is +1
Yeah.
to GMT.
I think it's Central Eastern or something like that.
Yeah, Central Eastern time zone.
Central European time.
European time zone. Yeah, yep, that's right. So definitely check that out, especially if you're in the EMU community. We're limiting that one to 100 for our first go around because we're kind of still, getting a couple of the kinks out, and we want to make sure that we have a good process for everybody who is there. So going to be 100 folks that we're going to be doing this training with, but then there will be plenty more that come on after that. So if you register and you don't make the cut this time, then we'll have plenty of these to follow on in the coming months after that. Okay, and then that's the events that I'm covering. There'll be a couple other events that are coming up the rest of this month, and a couple as well in the U.S. Those will be linked in the show notes. Wanted to just kind of highlight some blogs that I found over the last week that were really kind of cool. This guy has this blog, Java Helps, and so he's also on our community, and I just found a couple of his blogs like super user friendly, very helpful, and a good majority of them are actually. One of them is called like Presto for Newbies. Another one is like how to set up your environment if you're trying to actually develop on Presto. And he just does a really good job at kind of extending on what our existing documentations have. In this particular one that I'm showing here, and sorry for the podcast listeners, you can just go on and look in the show notes, but this one's called Presto SQL Join Algorithms. And what this is going to show you is it kind of talks about some of the concepts that we'll be covering in a couple weeks that build up to dynamic filtering, and it kind of describes what a build table is, what a probe table is, and that builds up the understanding that you need to kind of understand this kind of distributed hash join, which is one of the big underpinnings that we'll be discussing in a couple weeks to how Presto achieves its speeds, how it's how the query that you run gets distributed. So this is I think a beautiful blog that just breaks it down very nicely. That'll be linked in the show notes, so definitely check those out. And he has a couple other ones. And then let's see. I think there was one other one I wanted to show. Let me hop down here. Oh, this one actually. So I wanted to link a one blog that was a Medium blog that I don't particularly have access to, but has been really upvoted. It's actually somebody who's deploying an enterprise Presto on the Google Cloud, and so I haven't seen this. Most of the current enterprise Presto things that have surfaced recently have been all around setting it up on AWS. So I'm kind of glad now that enterprise Presto is showing up. Starboard's enterprise Presto in particular is showing up now that they've been available on Google and all these other ones. You're starting to see people write about this, and so that was kind of cool to me to see that people are actually using this in Google and other cloud platforms. So I linked that as well in the show notes. So definitely give that a look if you're somebody who's looking into using your enterprise Presto, or you want a more professional version of Presto, but you're on Google Cloud Platform and your company doesn't have anything to do with AWS. So really looking forward to see more and more of those in different cloud platforms pop up. So with that, that's pretty much the news. I'm gonna hop right over to you, Manfred, to talk about our concept of the week this week, which is going to be Hive Partitioning. Take it away.
Yeah, Hive Partitioning. Hive Partitioning is one of those concepts that you kind of need to know a little bit about, because with Presto you dive into the depths of managing your Hive metastore a little bit more, or you can. It's important to do that. Now, where does it even come from, and what does it even mean? It comes out of the relational database world, where partitioning your data kind of happens under the hood, and it's a concept that you just didn't care about, right? Like you just created a table, and like you under the hood, what happened didn't really matter. Well, with Hive, you want to understand this a little bit better. So literally what it does is Hive normally creates a directory, and the files that represent the data are just thrown into that directory. That's fine, obviously, if you don't have too much data, but Hive and Hadoop file system and others are obviously used with lots of data. And then you need to come up with a mechanism to break that up. And that's partitions. And it sounds fancy, but what it really is just a way of creating subdirectories or folders within those tables that are represented by those directories. And Presto obviously supports that. Typically, when you want that happening in Presto, what you do is you do your create table statement so that the metadata of that table gets populated into Presto and like for Presto into the Hive meta store. And you just add a with partitioned by statement, which then has an array. And in that array, you have one or multiple fields from within that table, which cause the partition. And which one of those fields you want to use there is kind of important because it depends on the table, right? Like a very common use case is you use something where over time it changes, right? Like if you do some sort of log data or so, you do it by that date, and then you end up getting basically a new directory which with each day or whatever, right? Like could be month, could be year even, but typically it's all the way down to the day. And what that makes happen is when Presto runs a query then, and that typically is then socialized around some query that has a where condition on that date. And then the read operation from Presto can say, well, I know where those directories are, and it just looks at those directories. It doesn't have to worry about looking at all the other data. The partition makes the I/O much, much less. When you then want to do this even more, you can have additional fields like something that doesn't change too much, right? Like some sort of lookup data, like a reference data, like a country on an address or something like that, or a city maybe even if it's more fine-grained, that kind of stuff. You don't want to do it by street number or like house number, so that doesn't make sense, right?
Yeah.
So it's something where there's a horizontal kind of data.
Yeah.
And then that makes more subdirectories and or optimizes the queries even more. And there's support around that in Presto to, like for example, you can delete those partitions. You can work on them to get them compacted individually and all that kind of stuff. So it's very useful to do that.
Yeah, and one point to that is like a lot of people get confused when they talk about partitioning. There's a similar concept called bucketing in Hive, and so if you were talking about with time, a lot of times when we think of partitions, you see a lot of times it's a date type of thing, and then you'll see other fields that are bucketed. Basically, what a bucket means is that you'll see like different directories of so going back to partition. Partition deals with like different directories, and that's shown in the HDFS is going to be different directories and have
yeah, and you can read those values, like the directory names or something like date equals blah. So it's like very user friendly, right? And when you're talking about bucketing, it's hash values. It's like, whoa.
Yeah. And so if you have like let's say we have a date value for our partition, and then we have like let's say we pick some other field like a customer ID. So and I think these are in my mind these are the two like kind of go-to scenarios for bucketing versus Hive Partition. And so what you want to avoid with Hive Partition and kind of the big oh no gotcha is like if I don't want to have my partitions I want them to be roughly symmetrical in terms of the size and I want them to be very evenly distributed. I don't want to have necessarily any kind of like bucket that's going to be bigger than the other. Sorry, not bucket. Partition that's going to be bigger than the other. Yeah. So over time, you're going to probably assume that like most days, you're gonna be able to have. I'm thinking of bucketing. Partitions is actually okay to do this. Let me flip this around. So partition. You can actually have different sizes, and where you want to be very careful about the even distribution is when you're talking about bucketing. So in a bucket, you're actually going to have all of these files, basically these, let's call them org files, and assume that everything is kind of stored in org. You're going to have these binary org files sitting in the same file and under the same directory. And then you're going to want to be able to basically go to the correct file that has your data in it. And so if you have, let's say in the customer ID scenario, you want to make sure that you chose customer ID because customer ID is going to be approximately, very evenly distributed across these different buckets. And so the nice thing about the bucketing is that if you have, let's say, a customer that is your like main customer that has a lot of data, and if you have a customer that is like maybe your smaller customer, maybe they map to the same bucket, and so approximately your buckets are going to be maybe around the same level of distribution. Whereas with partitions, you don't get that because you're making a very explicit split between, let's say a date. So you're going to say this year, or let's say this particular date, and all the data is going to go into that particular partition. Whereas you don't get that with clustering. Clustering, you're actually going to fill up based on you're basically going to get an even distribution by default. And so if you have something like customer ID where things tend to be not equally distributed, then you get that nice distribution just by kind of the eventually randomly distributing your big customers and your little customers kind of randomly across, well, not randomly, but by the hash function across your different buckets. So that was kind of what I just tried to say was trying to get to is that. And so with partitions, that's the other way around, is you will not have to worry so much about, making things like you're basically going to have things be not so equally distributed. So let's go back with the days of the week or something like that. Saturday, and Sunday, you're probably not going to get as much data in on those days versus the days that, during the weekday, because, most of the time people are more active on certain things, or maybe, weekends are when your
depends
data
if you run a
up.
sports website, maybe it's very busy on the weekend, right?
Yeah, it could go either way, right? And so you're going to have certain hotspots, based on that. And so that's when you want to use partitions versus clustering. And so, anyways, partitions, directories, clusters are actually splitting up your files and doing it over a hash. And so you get that distribution automatically with clustering, whereas you don't get that with partitioning.
And if you're querying, like you are if you are a Presto user that is just a data analyst starting to write queries into that Hive stuff, and you want to know, because you might want to write a delete query, because with deletions, you can only delete based on a partition in Hive, for example, with Presto. So you might need to know that there's hidden columns for all the Hive columns, like $partition, and you can query those and find out then. So if you don't necessarily know, because you might not have been the person that set up the table, you can find out that information by just looking at that special field. And same is for other fields.
Okay, cool. Anything else you wanted to cover? I know there was a piece that you were talking about that was saying, kind of relating this to the original partitioning that was done on old databases. I don't know if you mentioned anything about.
Yeah, just like in old databases, you didn't need to worry about that, right? Like it happened under the hood. It's like, well, implementation detail of whatever database. So typical users wouldn't have to care about that. But with all the other thing, what is like, it's a very big difference is what you have to keep in mind is when this goes into a HDFS storage or so, those different directories are actually on different nodes in a cluster of machines, right? Like they could be somewhere completely different. So it makes a huge difference if the meta store basically knows where those partitions are. So it doesn't have to go and look at like 5 different servers. It knows it's right there on that one machine, right? So it makes a big difference on the IO of like retrieving that data.
Yeah, it definitely is big, and we'll cover that here in a second when we get into the demo. So without further ado, let's go on to the pull request of the week and go into our little code scene here. I noticed that I had done a poor job at dragging us down into the bottom right here, so I'm gonna do that real fast and just make it
Move us
blatant,
around.
move us around here and make it blatantly obvious, so that way it's not like I was trying to be sneaky about it and somebody says, "Gotcha." All right. So, okay. So this week's pull request, let's pull it up right now. Is pull request. This is a bit of an oldie but a goodie. So this is pull request 223. This was kind of the early days of the Presto SQL days when things were kind of moving over into the Presto Software Foundation, and so. So we see this user. Let me see if I can say Haluo, and hopefully that was pronounced well enough. So how basically did this fix to this issue 174, which was add a Hive procedure to recover and discover partitions. And so you can tell why this makes a very fitting thing for us to demo on today, because we're talking about partitions. And so in Hive, there was basically this functionality called MSIC, repair table, and you may say it many different ways. It's literally MSCK, kind of like FSIC, for those that are familiar with like running that.
I think it's like FSCK is from file system check,
yep.
and M is from like
metadata, metastore. I mean,
or metastore check, basically.
Yeah, metastore check. Yep. So that's the idea here, is that they, Hive, and this is a kind of another thing, is like we weren't able to kind of just copy this syntax, right? Because that's not ANSI SQL. So this is a kind of a pointer to like when you think about like, well, why do we talk about ANSI SQL a lot with Presto? And this is the reason, is like we can't just directly use something like this. Instead, what we chose to do is we use a procedure. And so these are kind of general, like, functions that come along with Presto, and so we want to imitate this, but we can't just make up this word MSIC like things were done in Hive SQL. So since we're following ANSI, so that was just a small side point I wanted to make. But here's the actual PR. 4 file changes, very straightforward, but like very powerful stuff here and very useful. So I'm gonna kind of try to motivate why you'll eventually need this. So this kind of comes back to understanding how the Hive connector works in Presto. So getting back to this, you have like the Hive runtime, you have Hive file storage, and then you have the Hive metastore. So when I show you this, when we create these partition pieces of data, that information of like where that partition lives and kind of that partition even exists is all stored in the metastore. And then the data itself is actually stored in file storage. So what can happen at times is you can maybe have, let's say, some process that you've created, some maybe nightly process or something erroneously happens where you delete this file storage or basically the data in a particular Hive partition directory. You're gonna have that data deleted by something other than Presto. If you delete it through Presto, Presto knows to update both the metastore and file storage. But if you do it in an external process, there's nothing really blocking, as long as unless you've made it kind of an access denied thing. But let's say you have a user that runs this service that deletes.
Well, it could be a totally useful and like regular, like with our date example where we talked about before, it could be a regular maintenance, like anything that's older than 5 years, you archive it away and like it gets archived and deleted, right? Like it can be total normal operational stuff where you don't need to muck around with like Presto.
Yeah, let's not make it a bad thing. Yeah, let's talk about the good.
Yeah, it could be totally
reasons.
normal to do that, right?
Fair enough. Yeah, it's a good point, Manfred. So then we have this nightly process that we have running that just deletes certain data, but unfortunately, like it's not good enough to just delete that data from the storage. You also need to make sure you update that in the metastore. And so one way to do that is you could just go through Presto and maybe just use like some sort of a JDBC call or any other kind of client method that you want from there. Or you can go and delete the data, and then you would have to make sure that you follow on and update the Hive metastore to make sure that that partition that you're deleting is actually gone from the metastore. And vice versa, you could have another state where you leave the data in the file storage, but then it gets removed from the metastore. So all of these things. So this would be a case where maybe some ingest tool brings in the data in and then doesn't tell Hive. And so when you run Presto, it's all of a sudden you're like, well, I just ingested all this data. Where is it? And so you have to actually update Hive metastore. And so these are kind of like the two pieces that when you're thinking about this architecture, you have to always be cognizant of that when you're setting up these processes. So again, we're here using MinIO as our local little S3 storage, and then we have this bucket called part, not to be like a order part or any kind of like that, but this is part for partition. And then I have the dbeaver client instance connected to Presto, which is pointing to S3. And then we also have the dbeaver is also connected to the metastore database. And this isn't like the actual this is the actual database that sits underneath the Hive metastore. So if we go back to this diagram, sorry for those that are on the podcast, but check out the diagram in the Hive blog that I wrote a while back. It's basically Hive metastore is the service that sits on top of this other database that is not the same as the area where you're actually storing the data. So we have two kind of stores, and so one I'm talking to Presto, and the other one I'm literally talking to this database that's sitting here underneath the Hive metastore. So and with this, we'll get into a little bit of how that data is modeled in a second. I'm not going to go too far in the weeds about it, but it's just enough so that you can understand what we're doing there. So first, let's look at our schemas in MinIO. So we don't have any schemas, I don't believe, that are outside of the default ones. So we need to actually create that schema that points to that part bucket that I just showed you in MinIO. So we do that by create schema, minio.part, and that points the location to that location in MinIO. Now we're going to create a table. First, let's create a table with no partitions and see what that looks like. So we're going to create this table, minio part, and we're going to call the table no part. And it's going to have three fields: ID, which is an integer, a name, which is varchar, and DT, which is a very common shortening for date time, and that's also a varchar. So we're going to do that with the format in orc for all of these. So I won't say that for the rest of the tables that we create. Great, the table is created. If we go back to MinIO, we can see that there's now a little directory for in MinIO for no part. So let's go ahead and insert some data in there. We're going to insert 6 rows. 1, 2, 3, 4, 5, 6 is the IDs. Part 1 through 6 is the name. And then we are going to basically just have 3 different dates. The first 2 are on the 18th of November. The second 2 are the 19th of November of this year. And then the last one is on the 20th of November of this year. So we entered those values. And let's go look in here. And there's one orc file sitting here at 502 bytes. Cool. So if let me go ahead and run a quick query. If I do a quick query on no part where we are querying where date time equals 2020 11/20. So we say select all from minio.part.nopart where dt equals 2020-11-20. We get just those two, the 5 and the 6 parts back, which were dated on the 20th. Cool. So that's everything as we expect it. Let's go ahead now and create another table called orders. I should
In
just call
this case,
this.
it had to read the whole file, though, right? Because there's only one.
I'll get to that here in a second, Manfred. But yes, definitely it has to read the whole file. So we'll create a table called orders. I should probably just call this part, but now I've already made the demo, so too late. So these are going to have the exact same set of fields. It's going to have ID, name, and DT. But we're going to have this extra outside of the, we're going to say with format orc, but we're going to say with partition by equals, and this is the thing that Manfred was describing before. Partition by and then it points to this array of values. And so this is going to be array, and there's one string in there that says DT. And so that DT is talking about this last field here, last column here called DT varchar, and that's what we're going to be partitioning on. True to how it was done at Hive, everything that you partition by, anytime you add a partition field, there's a special rule in how we create these tables where the last fields, basically any field that you want to partition by has to be the last fields of the table. So in this case, we have two regular columns, and then there's one partition column, and so that has to be in the last field. I'll show you in a little bit when there's multiple fields how that has to look, but that's just something that worth pointing out now. So we're going to run this create table minio.part.orders, and it's going to have all those three fields with that partitioning on the last field DT. Create that, and let's go ahead and insert the data in. And again, we have 3 dates here. So let's go back up to our part. And now we have this thing for orders. And now instead of seeing one single org file that's sitting in there, we have now underneath the orders directory in minio, we have these 3 directories that say dt equals 2020 1118, and then we have another 2 that's saying 1119 and 1120. So we have 3 directories here, and if we go into each of them, we see that there's an org file in each of these, and each of them saying size 363. So let's go ahead and run the query on that.
I just want to point out that that's that aspect of partitioning that's nice, where you can literally read the directory name and it makes sense. Like,
yep.
8 is a value, right? So
exactly,
it's pretty in your face. So
yeah,
it's nice to manage. Also, once you poke around on the file system, it's useful.
Very useful, because if you look at here, like when I'm putting where dt equals 2020-11-20, that's the exact same, obviously without the little asterisks around it to make sure to quote. Without the little quotes around the actual string, we have dt equals 2020-11-18. So you may be thinking, okay, well, that's cool. Let's just check out. Let's see if this actually works. So in the same way in the last table with no partitions, this table with partitions also returns the same too. But there's a difference going on underneath the hood. Presto is aware that this is a partition table, and so it's going to, when I put this where statement here, dt equals 2020-11-20, it's basically indicating to Presto, hey, you need to make sure that check to see if there's any partitions on this table. Oh, there is? Okay, let's see if that's the field that we're filtering on. And it's going to say, okay, this is actually a field that's a partition in here. Let's see now if there's any, if the value for this, basically this DT equal statement, let's see if there's actually a partition that exists for this that can point to one of these directories. And sure enough, it does. And so it goes into this directory and reads this file. And so this is a small amount of data. We're only dealing with 6 rows, but you look at the size here. There's and particular for orc, there's a lot of extra size that's being involved here in terms of bytes for header and footer and all this stuff. So it's not going to be a huge difference, but you're going to look at 363 bytes in one of the partitions file sizes. Whereas if you look at the no partition one, that's 502 bytes. That's because we have all the data in one file versus here we have just a subset of the data in one of these smaller files. And so Presto only goes here instead of these other two and looks at this smaller file. And so when you scale this up to terabytes of data, that's going to save you hours.
Yeah, like the typical Hive table. So it doesn't just have like 2 little files or like 2 little like fields. It'll have like 10, 20 or more, right? Like
yep.
Sometimes hundreds. And then often those are like varchar values and whatsoever, right? And like if the numbers are small, but it's like probably like a 40% reduction on those small files, and it gets bigger, the reduction is even more. So it makes a huge difference.
Yep. So before I'm gonna eventually hop on to show you multiple partitions, but before we do that, let's take a moment to understand how this partition data is actually stored in the metastore. So I'm gonna be linking this in the show notes and showing this real fast because I don't want to talk too much to something that anybody who's listening on the podcast can see. But there's this huge model of tables that exist in the metastore, and so small subset that you actually need, but you basically and luckily for us, we had this diagram that was generated from the Metastore database by this guy that's called Niftimus Maximus, and he has this blog called the Analytics Anvil. He generated this back in 2016, so this may not be reflective of the Hive Metastore model that we know today in HTTP3. I'm sure a lot in this little transactions box that is being modeled has probably blown up since HTTP3. So this is probably not even representative of everything. But in terms of the basics of like how databases and different columns and things like that are, and partitions in our particular case that we're about to see are stored, this is a good like kind of initial reference to understand how metadata is stored on these tables. So let me go without too much talking it up. Let me go in and actually show you how we would run these queries on this. So I'm actually going to run a query on the Metastore. And so I need to make sure I'm using the Metastore database that we're actually pointing to. And then I'm going to do a select all from this table called, it's always, everything's in caps in this schema. So it's select all from DBS. And so this is your databases table. And so as we can see, we've created what's equivalent to a scheme, and Presto is called a database in the Hive model. And so we have this database, Hive database called part, and that's the one that's pointing to the min.io location of S3A : / part. So that is basically how you'd see a database. Let's go ahead and look for the tables. So to actually pull this out, we're gonna do select so let's go from the joins. We're going to join the database table that I just showed you with the TBLS table, which is the tables in the Hive Metastore. And we're going to just join those on the database ID. So, and then we're going to look for where the database name is equal to part. So we're basically saying, show us the tables. This is kind of what Presto does when it's asking, hey, show me all of the tables in per part. And so it's going to show you no part and orders. These are the tables that we just created in those set up just before. So it's, you can see a couple other fields in here that it's a managed table. These are things that are kind of more context specific to Hive, but really not relevant to our discussion here today. You can do even further things. You can kind of understand the kind of locations of where the tables are. So if we say for the table name orders and for the database name part, where's the actual location of that data? And so you can actually find that location there. What is this? You can even go into understand, what's the serializer class in Java that I actually use to deserialize and serialize that data. And finally, one last quick little thing. I'm not going to go into the actual query itself. These are all going to be posted on the show notes. But you can actually, show the columns. Now you'll notice that the columns don't include that DT. When I'm looking at the orders table here, it doesn't include DT because that's treated as a special column, as it's the partitioned column. So if we want to actually see the partitions here, we can actually do a select. So there's going to be a multiple joins. We're joining a database table in Metastore to the tables in Metastore to partitions in Metastore, and then one last table, which actually is called the SDS table, and that's just where the data. That's just the storage table. That's basically where data is actually stored. So all of this data gets joined, and we're going to basically show the partition, and we want to show the location of the storage as what we're actually going to be projecting in this query. So that pulls up, the different partitions that we're seeing, and one partition is this 2020 1118 based on that data. So you see the part name here, that's the partition table entry, and then it actually maps to a location that is in the min.io. So that's how Presto basically pulls that data out, and this is getting back to like why we call the Hive connector the Hive connector, because this is all the Hive model, but it's how Presto is basically using the Hive model to understand this syntax and this data, and pulls this information out to basically know where to find all this data. So it uses this part name to map from your query, and then say, okay, this is where it's at in min.io. Cool. So what we were talking about before, now let's get to the actual PR demo. So we want to actually get to these scenarios where what I have in my meta store is not the same, and it's not in the same state as what I have in storage. So I have this kind of mismapping of what is going on in Hive Metastore versus what is going on in the file storage. So we need to get to that state. In order to do that, let me first back out here, and I'm going to download the 1118 file. So let me go ahead and download that. And I actually have one from something I was doing earlier. So let me, and I just duplicated it. I want to delete it. Let me quickly just delete those on my desktop real fast. Cool. Now we're actually going to save this file, and then I'm going to go here and delete this 1118. Cool. So now that that's deleted, we should expect.
Now you just deleted it with that delete statement, the SQL statement where Presto allows you to delete it because it is a partition, right?
Yep. So I deleted the partition, and so what we expect to see in the Metastore, since I deleted this with Presto too, this isn't going to come get us into the bad issue, right? The data gets deleted from Metastore first. Or maybe not first, but gets deleted from Metastore, and then I can also look into min.io and check that data also did get deleted in min.io, and that's because we ran it through Presto versus some external process, right? So,
and without partitions, that wouldn't be possible. If you wouldn't have that table partitioned, you wouldn't be able to actually delete that.
Yep, exactly. So that is a huge convenience that offers us. So let's go ahead and move over to now adding this data back. So let's say I'm coming in as this, external process. Here, I did something wrong here. DT equals 2020. I'm creating a folder in min.io now to basically simulate that there we go, that I'm maybe some ingest thing, some sort of process, some ETL process that's pulling data in. And now I'm going to pull this data that I just put onto my desktop here that we had saved from before. And so now we have data existing in min.io, and it doesn't still exist inside the Metastore. So we're getting kind of a bad state right now, because if we go and run a query on Presto, let's go ahead and run select all from min.io.parts.orders. We're going to see that the 1118 data is still missing from there, even though we added that data back. So Presto basically has no way of knowing, hey, how do I find this data? So what we have to do, we can call this procedure sync_partition_metadata, and then we have to first thing that you need to know is that in the connection, we need to make sure that our connection, we have selected the catalog that we are actually doing this update on. So this is a Hive catalog, and in our Hive catalog, I happen to call it min.io. But you might be calling it Hive, you might call it whatever you call it. But you need to make sure that you're in the catalog that you're actually trying to update this query on. So in here,
can you use the use so and so statement as well?
I think I don't know how that works in Presto. Is that something that you can do?
Yeah, it's a Presto command where you can say use either schema catalog or use catalog.schema, and then you're basically in that context. So you don't necessarily have to do it on the connection.
Is that the exact syntax? Can we try that out real fast, or do you want to not?
Yeah, sure.
Okay,
yeah.
Let's go. Let's give that a shot then. We're going to take off so what I was doing before is that I was basically setting this up in the JDBC connector, which is one way that you can do this. But Manfred is kind of telling me we can use, and then what was it? Catalog?
Name of the catalog. Just use min.io.
Use, min.io. Okay.
: and run that.
Okay, let's go ahead and do that. Catalog must be specified when session catalog is. Oh, so this is
Okay, so you have to go. Then you have to go minio dot part or whatever.
yeah. So this is
But that might not work then.
well, no, it's fine. I think this is because I set this on the JDBC connector before, so that's why it's failing here. But that is useful to know. I just set it on here. So one way or the other, you need to make sure that you have specified whether it's in the JDBC connector, like I was doing here. So I specified the database here, which is, or the catalog in this case. And so I'll go ahead and update that one more time again, just to make sure that this hopefully doesn't fail now. And then once that's set up, you specify the schema, which is the Hive database, which is called part. And then you specify the table that you need to update, and then the mode. So the mode basically says is talking from the context of the metastore. And so in this case, we're missing a metastore statement, so we need to add that metastore statement back. So don't get confused in thinking like this is adding, to the storage. This is adding to the metastore. So we need to add that entry to the metastore. So we run this now. We call it call. Basically, to call a procedure, you use the keywords call system.sync_partition_metadata, and then part orders add. So we call that, and then that's called. And what we expect to see is that this metastore value comes back. Awesome. So that metastore value has now shown up in the metastore database. And now we would expect that when we do this select all, that we now should see all six rows that we initially entered in there. And sure enough, we do.
Yeah.
So that's how this works. Let's go with the other scenario. What if the data is missing rather than had been added by some other process? What if it's missing? So here we can just delete this 1120 data from min.io. So this is deleting it from min.io and not from the Hive metastore like we had before. And if we look here, still we see that this entry still exists in Metastore. So now what's going to happen? Let's go ahead and just run this just to see what happens. You still get this data is gone, but Presto probably did some kind of search under that for that directory and just realized it wasn't there, and then just exited that call gracefully. So it's not a huge deal if you kind of have this state where there's you kind of remove some data and it's sitting in the metastore, but it's probably better to just keep it clean. So you can call this drop command, and so running drop, we now should see that 1120 entry is gone. And so that's basically what this call is doing. And the final mode is full, basically saying if there's either scenario that's occurring, where there's some missing entries from Hive Metastore, or there's kind of missing data from the partitions in the storage, then you can actually run this, and then it's going to resolve all of those, basically running all adds, all drops that are necessary, and it's more or less a sync between the metadata and the storage. So that's pretty much that. I want to do one last thing to kind of show you and drive the partitions deal home, and this is going to be now, instead of with 0 or 1 partitions, we're dealing with multiple partitions. So we're going to create a table.
Before you jump into that, wait a second. I want to talk about that sync partition metadata. I think the reason there is these 3 functions where it's just add, just drop, or full is that there's significant performance impact on that. If you know that there's only deletions, then it doesn't necessarily have to do both operations of checking the file system and the metastore, right?
Yeah.
So it makes a big difference. So if you know what's wrong, it is advisable to only run the one drop or add, because it will take less time. Because on a massive storage system, a full run can take time, right? So,
yep, for sure. Good point there, Manfred. And yeah, that's definitely something to be cognizant of whenever you're running these. And so we're dealing with small amounts of data. So, but yeah, it definitely can run something like that. So since we're getting kind of low on time, let's go ahead with this multi-partition setup. So we're going to basically say, instead of just doing a DT field, we've taken the original ID and name, still are there, but then we're going to actually do multiple partition fields. So this is going to be splitting up on year, month, and day. And we're going to insert a couple extra fields this time. So let's go ahead and create that table. And we go back here, we're going to see that this table now shows up in multi-partition. And then let's go ahead and insert all of these. And so in partition by, you'll notice that we're not just doing it on one field now. We're doing it on the array of year, then month, then day. And those are all different strings in the array. And so when we look at what happens here, we go into multi-part in min.io, and you'll see that year, month, and day are now individual directories, all having that same format of year equals 2019, month equals 01, and day equals 18. And then we have a very specific org file that sits here on the bottom. Now, clearly, if your data is this small, you don't want to be splitting it up this much. This type of format, when you're partitioning, if you get about, let's say, a set of terabytes in a day, a couple terabyte, you want to probably just do it by day. But if you're getting to where you're really, storing, let's say, multiple, I guess on the higher end of, let's say, 500 terabytes and getting close to a petabyte scale, that's when you want to start considering maybe this type of granularity per day. Is that you're going to want to have the data be split small enough, and these are going to be getting you want to be cognizant of the size that these files end up becoming, because if they're too small, it's going to really affect the performance. And so you want to make sure that the distribution is approximately gonna give you a some file size of about, I don't know, like a gig, couple gigs or something like that. I don't know the exact recommendations, but if you're down to these bytes size here, you're probably not wanting to even do partitioning to begin with. You probably just want a single file like we did in the very beginning. So with that said, that's just some considerations with partitioning, and also to do with, same thing goes where like clustering, and hopefully was a good demo for you to kind of understand the Metastore. With that, let's move along to our question of the week. So I'm actually going to stay in the code view because I actually have some stuff to show. So in this week's question, we're answering this question of this pretty common, I shouldn't say pretty common, but common enough error that people tend to run into sometimes. So question kind of comes along like this: of why am I getting this query exceeds maximum columns? Please reduce the number of columns referenced and rerun the query. So this error, and you can see you'll get a stack trace, roughly what I'll be showing in the show notes. It'll say like compiler failed, and you'll see that message in kind of the top of the stack trace. So the user that was asking this is his name's Ashar Hassan. Very thankful that he contributed this and actually gave some good extra context around the solution. So he ran this query: select all, count one, and then from table group by all, having a count one greater than one. So what this is, it looks like a funky little select SQL statement, but what it's trying to do is it's trying to look for duplicates basically in this particular table. So what it's going to do is if there's a count that goes greater than one, it's going to basically be returned from this query. Otherwise, it's not. But to do this, this table happened to have, I think, 670 fields, as what he was mentioning. And so when you have that many fields, what Presto does under the hood is it actually dynamically generates a method to run this query. And so this is done with this library called, and this is linked in the show notes, this ASM library. And it basically does this Java bytecode manipulation stuff that we've kind of talked, a little bit about with like the performance pieces. And so it literally generates this Java code to be run on these systems. And for every field that gets projected out of any query, it has to generate literally like a parameter into this method. And so when you have 650 fields, it gets pretty lengthy, and the JVM itself actually has very strict limits on like how big this can be. So And so, if you want to learn more about that, I've linked the Java 8 and the Java 11 specifics on this of when we generate these things. It goes into this code length attribute here. So it says the value of code length must be greater than 0 and cannot, as the code array cannot be empty, but then it has to be less than 65,536, which is 2 to the 16th, I believe. So it's basically a very fixed amount of code that you can, or size of the code that you can generate for each of these methods. So when we run into that, what happens is we wrap this method to large exception that comes from this library, and we put it into this presto exception here that'll come out at you. So the solution at this point is maybe not a very satisfying solution. Basically, it comes down to there's some hacky ways that you can maybe get around this, and I'm not going to put those in there. The basic solution, and it will always depend on your specific query that you're running, is going to be to try to limit the fields. First thing is ask, like, do I need to project all these fields out? That's the first question. And so in this case, we're dealing with a group by every single field to look for duplicates. So in that
on
case,
a big table.
yeah, on a huge table. So it's like in that case, you need every single field to basically tell us something's a duplicate, right? Well, maybe in this case, and so what Shar did in this case is he tried to kind of limit to a subset of the fields that were probably the most identifying of fields in this case, and at least gave him an idea to have a smaller set of fields to look at further on. But in your particular case, you need to ask, okay, do I need to project all of these fields, and can I just kind of limit this down? And so a couple other solutions would be to kind of figure out how to disable the particular Presto functionality that is being invoked to write these methods. And so that's going to take a little more drilling. If you do run into this and you're kind of in that case of, I have this query and I need all of these columns. I basically need every single column as part of this huge table. You can definitely reach out to us on Presto SQL Slack, and we can work with your particular issue and see if we can find something around it. But it's just something to be aware of. Like if you run into this, it's basically a JVM limitation, and it's not a totally bad limitation that they've set
just
there.
think of it like this way. Like this is the only reason this is a problem in terms of like the number is because it's a massive table, and because we are code generating the code. Like no sane programmer would write one Java file which has 65,000 lines.
Yep, exactly. So that being said, that's the basic answer is try to limit your columns first, and then if that is not a possibility, reach out to us and we will try to definitely help you through that issue. So with that, I think let's wrap it up. Did you have anything else you wanted to cover before we said goodbye to all of our friends?
No, I think it's been good class. Nice demos, by the way. Very cool, very educational. And it's good to see the action happening.
Awesome. Well, thanks everybody that has joined this. One thing I want to mention is the music for the show is from the Mega Man 6 gameplay album by Krzysztof Slowakowski. And we definitely want to get everybody contributing any questions or PRs that they would like us to show on the show. We want to hear that from you guys, and let us know what things that you're interested in hearing. We are getting a lot of people talking about these Code Safari things that I've thought about doing, so we can maybe definitely look into that and trying to get some engineers on to have them roll in here. It probably won't be part of this Presto community broadcast, but it will be maybe another thing that we look into doing. So really look forward to that, and thanks everyone. We'll see you in the next 2 weeks.
Awesome. Thank you.